So on to infinite geometric series. We know it's an infinite series. You will see this right away. There is an infinite or infinity sign in your notation. And pretty much we're trying to see whether or not a series will converge. So sometimes when you add a bunch of numbers, they end up converging to one particular number. But if you add a bunch of large numbers, they end up not converging because the sum ends up being infinity. So it's a common problem in Calc 2. This is a really important one. We see this a lot more. We can't use our calculators to determine this all the time. We don't have the use of the infinity symbol. So all we want to do for ourselves is kind of just recognize what type of sequence we have. And if we do have ourselves a geometric sequence, then for sure, we know we have a formula for this particular type of infinite sum. So I'll do the same thing. One of my strategies is whenever I'm trying to figure out if something's geometric, I'll kind of write out the first few terms. So if I look at the first term, n is starting at 1, so I have 3/5 to the nth power, the first power. The next one would be 3/5 to the second power, 3/5 to the third power, 3/5 to the fourth power, and so on. And because there's not too many complications happening, I can already see, I see who my a sub 1 is. A sub 2, a sub 3, a sub 4, and so on. But if you try to figure out how do I get from a sub 1 to a sub 2, just by use of the power, you're actually multiplying by 3/5. Same story, a sub 2 to a sub 3, you're multiplying by 3/5. A sub 3 to a sub 4, you're multiplying by 3/5. And so this leads us to understanding we do have a geometric sequence with these terms. Or if we're talking about it in terms of sums, then we would call it a geometric series. So once we have that down, what we can do is you say, well, who is the first term? A sub 1 is 3/5 to the first power, which is 3/5. If you'd like, you can multiply it out just so that you see it. And our common ratio R happens to also be 3/5. Those powers of numbers often work. So the key here is to ask yourself, before you have a nice formula for this, you basically want to ask yourself, is this between 1 and -1? So it's 3/5. And that's what this is talking about whenever they see this notation. And so as long as that is the case, you could say, well, yeah, that's true. Absolute value of R is less than 1. It is, because if it was outside of -1 and 1, you would have yourself an improper fraction. Then if this is the case, all we have to do is find the sum. So we'll use our our infinite sum formula. That's a sub 1 over 1 minus R. And so what is a sub 1? We do have 3/5. R is also 3/5. Sometimes that's not the case. But we just do a little math together. We end up having 3/5 complex fraction. Now 1 minus 3/5 is 2/5. You want to do a little bit of division by hand, or feel free to use your calculator. This is the same thing as saying 3/5 divided by 2/5, which is the same thing as saying 3/5 times the reciprocal, 5/2. So we will finally get 3/2, and that is the infinite sum. So that particular series converges to 3/2. So just kind of a quick note in this course, you don't really have to prove if anything is in between -1 and 1. Usually it'll be obvious to you. They'll ask you to use the formula. But just wanted to give you a little preview of what you might see in a future math class. I hope this helps. I will see you in the next section.